Hey guys, I'm Sid and today we are going to discuss merge sort algorithm on geeks for geeks. So we have this statement given here, which is given an array, its starting position L and its ending position R. Sort the array using the merge sort algorithm. So we have to write a code here for our merge sort algorithm. So we all guys know that what merge sort is, and I am only going to write the code of merge sort here. Okay, so we have given merge sort, and we have given vector naming ARR, and our starting position is L and ending position is R. So we are going to apply a condition here, which is going to be if our L means starting position is less than R, which is ending position, then we are going to find our mid, which is int mid equals to L plus end minus L again and divided by 2. This is how we find our mid element. Okay, now we will apply again merge sort function for the left sorted array and one more merge sort function for the right sorted subarray. Okay, so not sorted subarray means we have to sort the array. We will apply merge sort function for the left array which we have divided and for the right array which we have divided. Okay, so we are going to write merge sort again array, and now our starting position is always okay L and ending position is going to be mid, not R. So this is for left subarray. Now for right subarray, merge sort array. Now our starting index is going to be mid plus 1 and ending index is going to be R, of course. Okay, now after sorting these all subarrays, we are going to merge these arrays again into a single array. So for that we will write another function which is going to be merge function, and we will pass parameters array and starting index L, now mid, and of course R. If you didn't understood what I have done here, don't worry, this is the new function and we are going to write the whole code for this function. Okay, so let's write our merge function here. We will create our merge function, which is void merge, and we'll pass the parameters. We'll create a vector here of type integer, vector int, naming it ARR. Then we'll have starting index L, and we are going to have our mid, then our ending index which is R, right? Now we will create a temporary array here, naming it temp. So vector of integer type and naming it temp. Why we are creating a temporary vector here? Because after sorting the subarrays, we need to copy those subarrays into a single array or our original array. So we have to create this temp array for the sorted arrays, right? And at the end we are going to copy this temp into our original array. Okay, so we are going to have our starting index. We will write int I equals to L. So I is always going to be the starting index for the subarray. It's not always going to be the 0th index. So we have divided our array into subarrays, so our starting index will always be changing. That's why we have initialized I equals to L, and j is going to be mid plus 1. Okay, this is applicable for all the sorted arrays. Now we will apply while loop here. While our ith index is less than equal to mid and our jth index is less than equal to r, then what we are gonna do here is, so this is our right subarray. Okay, so what we are gonna do here, we will apply one more condition, if condition. If our array of I is less than or equal to array of j, so what we'll do, we'll push back our array I, because we are sorting it in ascending order, so we will push our array I into the temporary vector which is temp. So we will do temp dot, we'll use pushback function, push back, which is array I. Okay, and after that we'll increment our I, which is I plus plus. So this is our if condition. Now we'll write our code for else condition. Else if array of j is less than equal to array of I, then we will push array of j into the temporary vector. So temp dot push back array of j into the temporary vector, and here also we will increment our, this is, so now we are going to sort the elements which are now left. So while I is less than equal to, we'll say mid, we'll do temp dot push back array I. Okay, then we'll increment again I plus plus. Then again what we are gonna do, we'll apply one more while loop here. While our j is less than equal to r, so what we'll do, we'll push temp dot push back array j. Okay, and again we'll increment our j. Now this is for sorting our subarrays. Now the last step which we have to do is to copy our temporary vector into the original array. Okay, so for that we will apply a for loop here. For, we will take a variable idx, which is obviously index, int idx equals to 0, and our index must be less than temp dot size. Okay, then we'll increment our index. We'll apply a braces here, and then for copying our index we'll do idx plus starting index, because our starting index is always changing for every subarray. So we will do idx plus start, means st equals to temp of index idx. Okay, this is how we copy our temporary vector into the original vector. So this is our code. Now let's compile and run it. Okay, it is showing a error here. Oh, it's okay. We have to fix the brackets here. Line number 23 here we'll need to put, sorry, small bracket. And one more error in line number 27, I guess. Array idx plus start. So here it is not start. We have taken start as L. Okay, now it has been fixed. Let's compile and run. Again line number 33 and 34. Okay, line number 33, int mate equals to L plus, okay, here end our end index is R, so we'll write R here. And in line number 34, I guess it is now being fixed, so let's run it again. Okay, line number 34. Oh, our s is small here, so this is all about learning how to write syntaxes. Okay, now let's compile and run. Okay, I think it has been fixed and our test case has been passed. Now let's submit it. Okay, okay, so I had attempted this question earlier, so again our accuracy is 100% of course. So it is showing two attempts here because I have already attempted one chance. So our question is solved here. So we'll meet in our next video. Thank you guys. Bye.